Differentiation video 4, where we look at applying the differentiation skills in other contexts. This goes with page 5 in your notes. Example number 1. There's a curve y equals x squared minus 4x plus 1. As with all these types of formula, this is a rule that says here's how you get the y coordinate for any x coordinate. If we take an x value and substitute it into this formula, we can work out the y value that goes with it. Particularly saying, what is the equation of the tangent when x is 3? A tangent is a straight line, and so immediately your mind should be screaming at you, this means we need the gradient and a point on the line. So, gradient for a curve, we can get a formula that tells us a gradient anywhere on the curve by differentiating. So, step 1, let's work out the gradient. First of all, get a formula for gradient. Because what we're differentiating is the form y equals, we're going to write this as dy by dx, not f dashed x, because the question said y equals. Also, because we're talking about gradient, the straight line, this means change in y over change in x at this any instant, and so this is a better form of the differentiation formula to use. Differentiate x squared. By now, of course, that's 2 times x to the power of 1 minus 4x becomes negative 4 because the power of x here is 1. And differentiate any constant, that's x to the 0, that disappears. So my formula for gradient anywhere on this curve is dy by dx is 2x, take away 4. So this equation tells us points. The first equation tells us points. What do points mean? Points mean prizes. In this case, getting your higher pass, or indeed a good band higher pass. First equation is points. Second equation tells me gradients. So, two things I need for a straight line, gradient and a point on the line. Gradient, in particular the gradient when x equals 3. So I'm going to say for x equals 3, my gradient, now since I'm now talking about a straight line, and because I'm used to doing y minus b equals m bracket x minus a, m is what I use there for gradient, so I'm going to now call it m. You can still use dy by dx if you want, but since we're talking about a particular place, and we're used to m. X is 3, so that says 2 lots of 3. Substitute in for the x. Take away 4. Some people write 2 times 3, that's absolutely fine. So my gradient, on my line that I've got, 6 take away 4, my gradient is going to be 2. Two things I need. Gradient and a point on the line. We said the first equation gives us points. Always remember, first equation points, second equation, my derivative, tells me gradients. So for y equals x squared minus 4x plus 1, I'm still saying this is for x equals 3, so I'm going to substitute 3 in for x. So my y equals 3 squared minus 4 3s plus 1. 9 take away 12 plus 1. Y is negative 2. So we are saying when x is 3, y is negative 2. This is my point on the line. Now I have a point on the line plus my gradient. So go to what is now my good old y minus b equals m bracket x minus a. We're looking for a rule that connects y values with any x value. So that states as generally y and x. M we've already said is 2. And remember for my point 3, negative 2, this is my AB point in the rule. Y coordinate goes with the y, x coordinate will go beside the x. So y take away negative 2 is 2x take away 3. Break the brackets and tidy up. Y plus 2 equals 2x minus 6. I'm going to subtract 2 from both sides. Y equals 2x take away 8. That's one of my choices for the acceptable form of an equation of a straight line. And so that's it done. That's the equation of the tangent when x equals 3. My second example is on page 6. Consider the curve y equals 1 over 2x. Slightly different. Finding the equation of a tangent at a particular point is a typical exam question. This one's a little bit different, but we can still do it from the skills that we've already got. Find points where the tangents to this curve are parallel to the line x plus 2y equals 0. So again, we're talking about tangents and gradients because parallel lines have equal gradient, and so we're still going to be talking about differentiating. It's a matter of interest, whether you know it or not, y equals 1 over 2x. The graph looks something like this. And if you weren't sure, you could just try different values for x. Try x is 1, x is 2, x is 5, x is 10. As x gets bigger, my 1 over 2x gets smaller and smaller, and so gets closer and closer to 0. Never actually gets to 0, but it gets closer and closer to it. Okay? And indeed, you can try smaller numbers like x is a half, x is a quarter, and so on. You can't get to exactly 0 because 1 over 0, we're not allowed to divide by 0. And so the curve comes closer and closer to the y-axis this way, and again, never quite touching it. But whether we draw that or not, we know that we're talking about gradients for parallel lines. Parallel to x plus 2y equals 0. So let's find out what the gradient of this line is. So, starting with x plus 2y equals 0. 2y is negative x. Y is negative a half x. Again, x no lower than the middle and preferably at the top. Why did I do this? I could have written negative x over 2 because in this form it's immediately apparent that my negative a half is my gradient. So I'm going to write the gradient of this tangent that I'm looking for is negative a half because it's the same as the gradient of this line, and this line I've just worked out is gradient negative a half. So the gradient of my tangent, well, where do I get that from? Gradients of tangents of the curve come from the curve equation. So now let's consider and give attention to this equation up here. So for y equals 1 over 2x. Now, of course, as that stands, I'm not allowed to differentiate it, so I'll bring the x to the top. Y equals x coming up to the top, x to the minus 1 over 2. Now I can differentiate. So my dy by dx is multiplied by the power negative x to the minus 2 over 2. And then because this is a little bit clumsy with my negative 2 up here, I'm going to rewrite this as negative 1 over 2x squared. So that's my gradient for the tangent to the curve at any point. We're looking particularly at the point where my gradient is negative a half. So I'm going to say, okay, instead of dy by dx, I have a value to put in here now. So my negative a half equals negative 1 over 2x squared. I'm going to multiply both sides by 2 because I don't like fractions here. While I'm at it, I'm going to cancel my minus signs. So I'm going to end up with 1 equals 1 over x squared, because I've multiplied both sides by 2 to get rid of this divide by 2. Again, I've still got a fraction here with my x squared underneath, so I'm going to multiply both sides by x squared. X squared equals 1. And then what most people do here is to say, so square root both sides, x square root of 1 is just 1. We're looking for the value x equals 1. At this point, I'd like to say a classic mistake has been made. So often people do that. They say, what number multiplied by itself is 1? The answer is 1. But there is, in fact, a second answer. So, in fact, at this point, x squared equals 1. A better way to have written it would have been to say x squared equals 1. Therefore, x squared take away 1 equals 0. Why do that? Because I can solve this equation, again, going back to Nat 5 skills, by factorizing. And we would say this is the same as x plus 1, x minus 1 equals 0. We know that each of these brackets equals 0. So x plus 1 equals 0, or x minus 1 equals 0. So the second bit says x equals 1, which we had already worked out. But this one here says x equals negative 1 is another possible solution, because negative 1 times negative 1 is also plus 1. So there are two answers when I'm solving x squared equals 1. Now, some people are very happy over here to say, oh, x squared equals 1, and then they just remember, oh, x equals 1, and they say, oh, but there's a second answer of x equals negative 1. So my x equals negative 1 or x equals 1, and they remember there's two solutions to here. But so often people forget. The advantage of rewriting this and solving it this way, rather than just saying square root of both sides, is that it makes it impossible to forget the second value for x. What's happening here? Well, if we look at the curve, we were saying, where do we have possible values of a tangent with gradient equals negative a half? And we'd say, well, that's a line that probably comes something like here. And we're looking, there's a tangent coming down with a negative slope, but not too steep, gradient maybe negative a half. And we're talking about the coordinates of this point here. And we've said the x-coordinate is 1. Why is there a second answer? Well, because actually, once we get into considering negative values of x, this curve has another half, and it comes over here. And so there's a second line doing this, and the second line is coming down, same gradient, so parallel to the other tangent up here, and we're saying there's a second value here. And that's why there were two answers. Down here, we said x could be 1 or negative 1, and so up here, x is 1 or negative 1. The question, check you've done the original question. We've solved the x values, but we're not finished. Find the points where the tangents are parallel to x plus 2y equals 0. That's why the question said find the points, because there was more than one answer. But finding the points have two coordinates, so we're not finished yet. All right. Again, first equation tells me points. Y equals equations give me coordinates of points. dy by dx, that gives me gradients further down here. So I have two values for x, but I've still to consider what the y values would be. So we can say y equals 1 over 2x. So for x is negative 1, y equals 1 over 2 lots of negative 1. That gives me the point negative a half. So there's my first point. Y coordinate, x is negative 1, y is negative a half. But there's a second answer. For x equals 1, y is, again, 1 over 2x, so 1 over 2 times 1, y is a half. So my second point in my solution, 1 a half. So there are my two possible points that fit on the curve and where the tangent is parallel to x plus 2y equals 0. So a little recap of what we did there. Parallel lines immediately said, oh, that suggests we're talking about equal gradients. So we'll work out the gradient of the line, which is what we did here. Then we said we're talking about tangents with this gradient. How do I get gradients from a curve? I'll differentiate, which is what we did here, to get the derivative there. And then we set those equal to each other. My gradient is negative a half, which is, and then from the curve, minus 1 over 2x squared. We solve that. We said it's better to solve by bringing the minus 1 onto this side here so that I get two brackets to remind me for two answers. And then we substituted both of those into my first equation, because y equals equations, they tell me coordinates. And so I'll put y equals 1 over 2x, substituted in, got the first point when x is negative 1, got my second point when x is equal to 1. And that was the second example done. A bit trickier, but with practice, you'll absolutely get this.